Hello Krishna, hello Kulsum.
Hello, sir. Good evening.
Good evening. Am I audible properly?
Yes, sir.
All right. Everything good?
Yes, sir. Everything's fine.
Any doubts from this chapter? Investigative function?
No, sir.
No. All right. Prepared for the test?
Yes, sir.
Hello everyone. I hope I'm audible properly to everyone. All right. Today we're going to start the chapter continuity and differentiability. Let's wait for one more minute. All right. So first we are going to do this differentiability part, all right, differentiation part. Then we are going to do continuity, all right. So what is differentiation?
பைஜு
Anybody remember?
ரெண்டுலயுமே சேம் சாப்டர் இன்னைக்கு ஸ்டார்ட் பண்ண இன்னைக்கு இது பைஜுல நேத்து ஸ்டார்ட் பண்ணாங்க
Say your voice. All right. Does anyone know what differentiation is?
Derivatives.
Derivative, absolutely right. But what is that? You must have done this in class 11th, right? Differentiation is nothing but change of y with respect to x, right? This is called differentiation. But one condition is there: the change in x should be very small, and very small means almost zero, and that change in y is called differentiation. So who can tell me what is the differentiation of cos x with respect to x?
Minus sin x.
Minus sin x. All of you know this? Ronaldo, Shikhani, Kulsum, Said.
Yes, sir.
All right. These are the basic formulas. Differentiation of sin x.
Cos x.
Cos x.
Cos x. E to the power x.
Same, right? The same. E to the power x.
Absolutely right. E to the power x. Log x.
1 by x.
1 by x. What is left? Tan x.
Six square x.
Absolutely. Please note it down. If anybody doesn't know this, please write it down. Differentiation of x raised to the power 5.
5x to the power 4.
5x to the power 4. Everybody knows this, how this happened?
Yes, sir.
Yes, sir.
All right. Differentiate x sin x with respect to x. Please solve this one. I'll give you a few minutes.
Sir, what does with respect to mean?
With respect to x means you have to find d sin x, x sin x upon dx. All right, with respect to x. All right, Shikani.
Sir, what will be the dy dx of x?
Do we use product rule?
Right. We use product rule. And Shikani, what did you say?
Sir, what will be the dy dx of x?
D
One.
by dx 1, absolute right. Dx by dx. Whatever you change in x will be changed in this x. So that will be 1. All right. Or you can use that formula. This is x raised to the power 1. So that formula is n, that means 1 into x raised to the power n minus 1, 1 minus 1. So this is 0, 1 into x
Sir,
raised to
so
the
it will
power
be
0,
cos x, right?
sin x is cos x, right? All right.
Answer.
So the answer here, dx sin x upon dx will be x d sin x upon dx plus sin x into dx upon dx. So this is x cos x plus sin x. This is clear to everyone?
Yes, sir.
All right. Ronaldo, Said,
Yes, sir.
Yes, sir.
all right. Shikani, this is clear?
Sir, can you say again?
All right. Please note it down. Ishan, you are late today again. Ishan, am I audible? All right, let's move on. Next question. X upon sin x. All right, differentiate this. I'll give you a few minutes.
Done, sir.
All right. Who else has solved this? All right. Kulsum, Syed, Ishan, Shikani. Who doesn't know how to solve this?
Answer me.
All right. So this was the product rule, u into p, right? Two functions are multiplied. Here we have to use quotient rule, right? Division. If two functions are divided like this, u upon, let's write p like this. So if we have to differentiate like this, then what is the formula? V u dash minus u v dash on v square. All right. And dash
What
is
is V dash?
differentiation. V dash u dash means differentiation of this function. All right.
Okay.
This formula is clear to everyone.
Yes, sir.
All right. So please solve it now, Shikhani. I'll give you 2 more minutes.
They're done.
All right. So here answer will be sin x minus x cos x upon sin square x. Right?
Yes.
Everyone, this is clear. Kulsum, Saeed.
Yes, sir.
All right. Saeed is not there. Ishan,
Yes, sir.
this is clear.
Yes, sir.
All right. Now this is the division of class 11. Now what is in class 12? First we should write explicit function. What is explicit function? The relationship between x and y is given in such a way that we can easily solve for y equals to f of x. All right. So we can write y in terms of x. This function is then called explicit function. All right. Or you can write then y will be called as the explicit function of x. Same thing. Note it down and explain what this means.
So what
Sir,
is
can
after
you read the
hence
third
written?
line?
Let me read the whole line. The relationship between x and y is given in a such a way that we can easily solve for y equals to f of x. Hence, we can write y in terms of x. This function is then called explicit function. You can write down in your own language. Let me explain, then you write it down. All right, let me explain first. What they are saying, suppose I give you a equation x square plus xy equals to 5. So I can write xy equals to 5 minus x square. So y equals to 5 minus x square upon x. So I can say here that y is a function of y, x. Right? We put some value of x and we can find the value of y. Or we can separate y and x individually. Right? We can write y in terms of x. This is clear.
Yes, sir.
So this will be called explicit function. And we are writing the same thing here in definition. We can easily solve for y equals to f of x. So this is solving for y equals to some function of x. All right, I hope this is clear. Note it
No,
down.
sir.
No, Shekhani?
No, sir.
See,
I don't understand.
You will get this after I explain the counter argument of this. All right, just write it down now. Just write it down. Give me 5 minutes. Then I'll ask you again. All right. Done?
Done, sir.
All right. The opposite of this is implicit function. The definition of it would be the function where we cannot solve for y equals to f of x. And y will be an implicit function of x. What this means, if I give you a function y square plus xy plus sin xy equals to 0. Now, Shekhani, can we write y in terms of x? What this means here, you can see y equals to 5 minus x square upon x, right? There is no y on the right hand side. But in this case, we cannot separate them. Even if I write y square plus xy is equals to minus sin xy, there is no way to separate x and y individually.
So y should be on one side and x should be on the other side.
Right. Okay. So that would be called explicit function. If you cannot do that, that would be called implicit function. All right.
Yes.
Everyone, this is clear.
Yes, sir.
All right. Note it down. The examples also. Done.
Done,
Done,
sir.
sir.
All right. So this we are going to use later in the chapter. But first, let's solve some differentiation questions. So I'll be giving you questions. You have to tell me after solving that. First question, let's say find dy upon dx for each of the following. First is 2x plus 3y equals to sin x. All right, try to solve this one. I'll give you a few minutes.
Done, sir.
All right. So how we can solve this? If they are saying find dy by dx, then let's just differentiate each term. So what we can do, differentiation. So differentiation of 2x upon dx plus differentiation of 3y upon dx is equals to differentiation of sin x upon dx. This is clear, everyone?
Yes, sir. Sir, the first one will be x square, right?
No, 2x. See, any constant, if you have multiplied any constant with the function, then the constant comes out of the differentiation. All right. So this will be 2 times differentiation of x plus 3 times differentiation of y is equal to, this is differentiation of sin x is cos x. This is clear, Shekhani?
Sir, what formula are we using for that? For the 2x?
Formula, this is the property of differentiation. If we have differentiation of k times any function, k times f of x, then the constant comes out of the differentiation and we can differentiate like this. All right.
Okay.
All right. Or if you really want to know how we can like prove this, you can use uv form. All right. You have two functions, 2 and x, right? These are two functions.
Yes.
So first 2 into differentiation of x is 1. Yes or no?
Yes.
Plus x time differentiation of 2.
0.
So this is 0. So the answer is 2. Here also we can get 2 because differentiation of x in terms of x is 2. All right.
Yes. Plus.
So this is clear
3.
now.
Yes.
So plus 3 dy upon dx.
Sir, dy will be 0, right?
No. Not we have to find dy upon dx, right? This is what I'm trying to find, the change in y with respect to x. All right. So dy upon dx. Clear? Y is a
Yes, sir.
variable here, Shikani. Y is not a constant. If they have given you y is a constant, then we can say this is 0. But y is a variable. All right. Ishan, this is clear?
Yes, sir.
All right. So this is cos x. So we can write 3 dy upon dx is equals to cos x minus 2. And lastly, we can say dy upon dx equals to cos x minus 2 upon 3. Any doubts in this? Anybody?
No, sir.
All right. Shikani? All right. Shikani falls silent in between the classes. So let's move on. Next question. Two x plus 3y equals to sin y. All right. Here also find dy upon dx. All right. I'll give you a few minutes. Try to solve this.
Sir, the answer will be cos y minus 2 by 3.
Yes. Here I've written the answer. Cos x minus 2. Oh, you are saying this or this?
Cos y, no, the second one. Cos y
Second one.
minus 2 by 3.
I'll solve it, Shikani. No worries. Give me 2 minutes. Let everyone solve this. All right.
Done, sir.
Done. Everyone has solved this?
Yes.
I've got a different answer though.
got the different answer. All right. Let's see. Again, simply differentiate all of the terms here.
Sir, can you show the first question for 1 second?
All right.
Okay, I think I made a mistake. Let me do it again.
As they write in roads, Shekhani, speed thrills but kills. Right. So solve every question carefully. So what we can do here, take 2 out. So differentiation of x with respect to x, plus take 3 out, differentiation of y with respect to x. Now here, see this function is in y, but differentiation is happening in x. So what we can do here, differentiation of sine y with respect to y and differentiation of y with respect to x. This step is clear or not to everyone?
No, sir.
No. All right, let me explain. See, Shekhani, when we write dy upon dx, Shekhani, you are a physics student or not? Like your commerce, science?
Yes. No,
Yes, right?
science.
So if I say y is displacement and x is time, suppose I tell you ds upon dt, what does it give you?
Acceleration.
Velocity, right? Displacement upon
Velocity,
time.
velocity.
Velocity.
Sorry. Yes.
So what is velocity? How much displacement you covered per second, right?
Yes.
And that is where you calculate the speed, right? Yeah, when you ride a bike or car that says 50 kilometers per hour and so on. So that is speed. And in velocity, we count just the direction also. So how much displacement per second, right? So in that displacement is also given in terms of time. What I'm saying here is the displacement you are moving is in terms of time, right? For 1 second you are there, half an hour later you are in some other path or other place. So this distance is given in terms of time. If I give you y equals to 2x square plus 2, and I ask you find dy by dx, then what you will do? Differentiate this function d 2x square plus 2 and dx. Yes or no?
Yes.
Then you will write 4x is the answer. But in here, the function itself is in y, in terms of y. Here the function is sine y, and they are saying differentiate this with respect to x, right? Yes or no, Shekhani?
Yes, sir.
So how can we find a relation between y and x? Because if you don't have a relation between y and x, we cannot differentiate this. So what we can do, differentiate sine y with respect to y. Sorry, y, because we know differentiation of sine x with respect to x. So we also know differentiation of sine y with respect to y, right?
Yes.
Then we can differentiate this y with respect to x. Yes or no?
Yes, sir.
Let me explain in an easy language. All right, again, for everyone who still don't understand this, suppose I say for every 10 rupees I get, that means Akash gets, here Shikhani gets 20 rupees. All right, and for every 20 rupees Shikhani gets, Ronaldo gets 40 rupees. So if I ask how much money would Ronaldo get if Akash gets 80 rupees, then what will you do? You will take Shikhani also in the count, right? Yes or no, everyone?
Yes, sir.
Yes, sir.
Because Akash is related to Shikhani and Shikhani is related to Ronaldo. Akash and Akash and Ronaldo has no relation directly. So same way, what we are doing here is we don't have a relation sin y and x. So what we are doing, we are differentiating sin y with respect to dy, then we are differentiating dy with respect to x. This is clear?
Yes, sir.
All right, I hope so. So now let me rewrite this here. So this will be 2 plus 3y upon dx equals to, this will be cos y dy by dx, right? So we have 2 plus 3y by dx equals to cos y dy by dx. We can take dy by dx common, so we can write this 3 dy by dx minus cos y dy by dx equals to minus 2. So dy by dx taking common, 3 minus cos y equals to minus 2. So dy by dx will be equals to minus 2 upon 3 minus cos y. You can multiply this negative sign and write cos y minus 3. That is absolutely fine. This is clear or not, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Ishan, Shikhani,
Yes, sir.
all right. Note it down if you want. Then let's solve another question. All right, solve this question. 2-3 minutes for this also.
With respect to what?
The question says find dy by dx.
Oh, with respect to y then.
No, with respect to x, right? You have to find dy by
With
dx.
respect to x. Okay, okay. Sir, for by square, we'll use the identity d by dx into uv, right?
No, b is a constant here. A, B, C, A, B, A and B are constant. So you can just take them out.
Constant, so it will be 0.
No, if constant is in multiplication, then you have to just take them out, right? Differentiation of 2x is 2, or 2x square is 2 times 2x, so 4x.
Okay, okay.
All right.
Done, sir.
All right.
Can
Everyone
you
solve
do?
this? All right.
Yes, sir.
Let me ask. All right. So again, let's just differentiate. So this here, a is a constant, so I can take this a outside. So differentiation of x with respect to x plus b outside. So differentiation of y square with respect to x equals to, again, this we cannot solve directly. So differentiation of cos y with respect to y to dy upon dx. All right. In here also, this is dy square. So we cannot differentiate y with respect to x directly. So what we can do, write this dy, then dy upon dx. This is clear or not, everyone?
Yes, sir.
All
Yes,
right,
sir.
Shikani.
Yes, sir.
All right. So now we can say this is equals to a plus b into 2y dy by dx equals to, this is minus sin y dy by dx. Now let's take this together. So this is 2py dy by dx plus sin y dy by dx equals to minus a. So dy by dx will be equals to minus a upon sin y plus 2py. I hope this is clear to everyone.
Yes, sir. It's clear.
All right. Ishan,
Yes, sir. It's clear.
note it down if you want. Anybody wants to note it down?
Yes, sir.
All right. Next question. Xy plus y square equals to tan x plus y. Again, find dy dx.
Sir, what will be dy by dx of y?
It will be dy by dx. If you differentiate y with respect to x, this will be same, right?
So how do we differentiate xy?
using product rule.
Okay, sir.
All right.
So done.
Done, sir.
So done.
All right. Let's solve. Get the answer. Differentiation of xy upon dx plus differentiation of y square upon dx. Differentiation of tan x upon dx. Differentiation of y with respect to x. So here two functions are multiplied, so we can use product rule. So x times dy upon dx plus y times dx upon dx,
It should be
Plus-
2y, right?
right? 2y and y by dx. Don't forget this dy by dx. This is clear?
Sir, why did you put x dy by dx?
Same thing, Shikani, again, you cannot differentiate y square directly with x, right? You can differentiate x square with respect to x, right? Differentiation of x square is 2x, but differentiation of y square is not 2y. It is 2y, then you have to differentiate y with respect to x also.
No, not that, sir. The first one. D by dx of xy.
This, all right. In product rule, differentiation of, suppose this is u, this is v, then u v dash, that means differentiation of y, plus v, that means y, into differentiation of x, so dx upon dx. All right, this is clear, everyone?
Yes, sir.
All right, differentiation of tan x is this, differentiation of this is this. So let's just simplify this. Any doubts till now? All right,
No, sir.
let's take dy by dx together. So this is dy by dx plus 2y dy by dx minus dy by dx equals to 6 square x minus y. So dy by dx will be x plus 2y minus 1 minus y. Dy by dx will be equal to. Any doubts on this or not?
No, sir.
All right. Shikhani, Ishan, Ronaldo.
No,
Sir, can you
No.
do the right hand side again?
All right. So differentiation of tan x is Shikhani.
Sec square x minus
So this is
yeah,
this.
sec square x. Yeah.
And dy by dx. So I'm just keeping this as it is. This dy by dx went to this side. This y came to this side. All right.
Okay, yes.
Note it down if you want. All right. Next question then. If x square plus 2xy plus y cube equals to 42, find dy upon dx. All right. If x square plus 2xy plus y cube equals to 42, find dy by dx. and I need everyone's answer on this. All right, I will not be solving this until everyone has solved this at least once.
Done, sir.
Done, sir.
All right, everyone has solved this. Shikani, Ishan, Krishna.
Yes, sir. Done.
Yes, sir.
All right. Said,
Yes, sir, done.
Shikani.
Yes, sir.
Let's see. So here differentiation of x square upon dx plus 2 xy plus dy cube upon dx equals to differentiation of 42 upon dx. This is 2x plus 2 times x dy upon dx plus y plus dy square dy upon dx is equals to, Shikani, what is the differentiation of 42?
0.
0. And this step is clear to everyone? I'm skipping steps now.
Yes, sir.
All right. So this is equals to 2x plus 2x dy by dx plus 2y equals to 3 plus 3y squared dy by dx equals to 0. So dy by dx we can write minus 2x upon 2x plus,
Sir, in the second part, dy by dx of 2xy.
right, to see we can take this 2 common outside constant.
Yes.
Now differentiation of xy, x constant, differentiation of y dy by dx, then y constant, differentiation of x is 1.
So then again dy by dx should come, right?
No, you don't have to write again dy by dx because see x, let me write here, x dy by dx plus y dx by dx, right?
Okay, yes, yes.
Right. So I hope this is clear. See, let me explain what I am doing here. What is the difference? In this first term, we have dx square upon dx. So I wrote 2x because x square is a function of x, right, Shikhani?
Yes.
So I can find the change in x when I'm changing x, right? Yes or no?
Yes.
But in this last term, I have dy upon dx. Now I have to find the change in y when I'm changing x. So that is impossible. So what I can do instead, I can find the change in y when I'm changing y, and I can find the change in y when I'm changing x, right?
Yes.
So that I can write dy cube upon dy into dy upon dx. So this is change in y when I'm changing y, dy by dx. So dy by dx is as it is. All right. I hope this is clear to everyone now. Please match your answers. Everyone, yes or no?
Yes, sir.
All right. Let's solve another question. And this, take your time, solve carefully. If x under root 1 plus y under root 1 plus x equals to 0, and x is not equals to y, prove that dy upon dx equals to minus 1 upon 1 plus x square. All right. Solve this. I'll give you 5 minutes for this. This is a good question, not that difficult, but try to solve it in your own way.
Sir, how do we solve for roots?
Sorry,
How do we solve for roots?
I don't know. Try to solve it in your own way. Whatever you want to do, just solve it. Just differentiate it directly, or whatever changes you want to bring in this first, whatever you like. All right. I just want you to differentiate this. Let's see, differentiation and integration are the chapters in which the more you practice or the more things you do wrong, the better you will be at both of this.
Sir, can you do it?
All right. Anybody solve this?
So I have solved it, but I'm getting a big answer.
But the question says prove that this is this, right? So you cannot get a different answer. Anybody solve this?
Sir, solving the first equation, I got an answer, and then I have to differentiate that to get dy by dx, right?
Right, we can do that way. Absolutely. Ronaldo, what about you?
I'm still solving.
She's solving. All right. Syed.
Sir, I did not complete yet.
All right. So
So
who
I
did
got
like this?
close answer, sir. Not so close. Like minus y by 2 plus 2x.
Minus y by 2 plus 2x.
Yes, sir.
So minus y by 2, 1 plus x you are getting. All right, let's see. So in this type of questions, this is the thing they will play with, right? This is the trouble. If they asked you find dy by dx, then even this answer might be correct, right? If you did the differentiation clearly, or you can differentiate many more ways, right? And you will get different answers and they will all be correct. But the issue here is they have asked you to prove that dy by dx equals to this. So you have to reach to this point, right? So how we can do this? In this type of questions, now we can use that implicit explicit type thing. So what we can do? We can write x under root 1 plus y equals to minus times y under root 1 plus x. Now can we square both sides? So this will be x square 1 plus y equals to y square 1 plus x. Yes or no, everyone?
Yes, sir.
Now this is x square plus x square y equals to y square plus y square x. Now let's bring this x square and y square together. So x square minus y square equals to y square x minus x square y. All right. So here we can write x minus y, x plus y equals to, we can take xy common from here, y, and from here x will be there, and this we can cancel with a negative sign. This step is clear to everyone?
Yes, sir.
Yes, sir.
All right, now you can differentiate. See, we have reduced that function into something very simple. All right, now you can differentiate and see if you get the answer. All right, do that, till then I can check something else. All right, you guys differentiate this.
So can you explain again?
All
I'm
right,
confused on how it should start and how you should remove the root.
right. See, in this type of questions, there is clearly two ways we can solve this, right? First, we can simplify this equation, then differentiate, or differentiate directly, right? There is only two ways to solve this. So before differentiating this type of questions, we should always try to simplify this. Always. This is clear?
Yes.
So if you asking, sir, how would I know, right? So how would you know? You will know after this chapter is finished, because we are going to do so many questions. Then you will also get the intuition how to solve. All right, each question is something different. All right, Shikhani. So you will not
Yes.
get the idea in this type of questions in the first question, but after you solve, you complete the assignments, we solve many questions in the class, then you will get the intuition, right? So
Yes, sir.
how we can simplify this? I took one of that to one side, then square both side, and then the equation told for itself. All right, so everyone got the answer? Everyone has got the answer?
Yes, sir.
All right,
Sir, I'm
that's
getting
all.
different answers.
We are getting different answer. All right, Kulsum, how we can solve this? Kulsum, what will be the next step here?
Sir, I did it in another way. The answer I got here is minus x minus y is equals to xy. And then I took it as minus x is equals to x plus 1y.
Minus x equals to, all right, you took y common, then 1 plus x,
Yes.
right?
Yes, and then I got y is equals to minus x by x plus 1.
Absolutely right. So Kulsum, this is not the different answer. You can see this thing and this thing is exactly same. You just have written it on the opposite side, right? I can multiply a negative sign here and get the same thing as you, right?
Okay, sir.
So Krishna, now you got the idea how to solve this?
So I got minus y minus 1 by 1 plus x.
Let me solve this. Let's see what is happening here. Let's bring this to this side and this x to this side. So what we will get, y plus xy equals to minus x. So taking y common, 1 plus x equals to minus x. So y equals to minus x upon 1 plus x. Now this is, we can see is explicit function. All right, now we can differentiate. So dy by dx and differentiation of this whole function. So please differentiate this function and see what you get. All right.
So can't we differentiate directly x plus y, like differentiating d by dx of x and d by dx of y is equal to d by dx of minus x, right?
Let's see. You may get the answer that way also. So you will get 1 plus dy by dx equals to, taking minus common, y plus x dy by dx. All right. So what we will get from here, 1 plus y dy by dx common, 1 plus y divided by 1 minus x. So dy by dx is equals to 1 plus y 1 minus. Now what you have to do, again you have to put the value of y here from this equation, right? The same equation, you have to find the value of y, then put in here and you will get the same answer. All right, Krishna?
Okay, sure.
So you can do that way also, but same thing, right?
Yes, sir.
So do this, solve this, differentiate this. Shikhani, this is clear?
No, sir.
Not clear, please note it down. All right,
From the starting
try to
itself,
solve
it's
it.
not clear.
Sorry,
From the starting itself, it's not clear.
from the starting it's not clear. Which step are you not getting?
And sir, after x square into 1 plus y, the next step, how did it
How-
become x square y, x square y?
See, this y square came to this side, then x square y came to this side.
Okay, understand.
All right. So now this is the identity. A square minus b square is a plus b into a minus b. And from here I took xy common. All right. And now x minus y is there, y minus x is there. I can cancel out, but there will be a negative one. So I multiplied this negative one to this side, and everything is clear after that. All right.
Yes. Then where do we differentiate it?
We differentiated here. See, I simplified again. I got y equals to minus x upon 1 plus x. Now I differentiate. So in the left side we got dy upon dx. On the right we have to differentiate this function using quotient rule. All right. This is clear, Shehani?
Yes.
Please note it down. This is important question. Note it down. This is clear, everyone?
Yes, sir.
Yes, sir.
All right. So you guys have differentiated this.
Yes.
Yes, sir.
All right. Ishan, Ronaldo.
Yes.
All right. Let's solve another question. If sine y equals to x sine a plus y, prove that dy upon dx equals to sine square a plus y upon sine a. All right. Solve this. Anybody solve this?
Sir, can you solve this?
Right. Let me give a hint, and you can solve this very easily. Just write it sin y upon sin a plus y equals to x. All right. Now you can easily differentiate. So in this differentiation with respect to x, sin y sin a plus y equals to dx upon dx. So this is 1. And in here we have to use u by v form. So this will be sin a plus y. Differentiation of sin y is cos y and dy by dx. Right? Because we are differentiating y with respect to x, minus sin y. Then differentiation of sin a plus y will cos a plus y and dy by dx upon sin a plus y square. This is equals to 1. This step is clear or not to everyone?
Yes, sir.
All right, Krishna.
Yes, sir, clear.
All right. So now what we have, we can take dy by dx common, and this is sin a plus y cos y minus sin 1 to cos a plus y upon sin square a plus y equals to 1. Now can anyone tell me what we can do this? What we can do here? This is sin a cos b, sin b cos a.
So sin a minus 2.
So sin a plus y minus y upon sin square a plus y equals to 1. Y and y cancelled. So this is sin a. So dy by dx sin a upon sin square a plus y is 1. So just throw them to the other side, you will get the answer. All right.
Yes, sir.
Everyone, this is clear?
Yes.
All right. Note it down. So I hope this is clear to everyone, whatever we studied in this class. Yes or no?
Yes, sir.
All right. Now I'm sharing the test paper, and your test is starting in a few minutes. Please note it down first. And I would request everyone to start the video and audio, and give me 2 minutes. I'll share the test papers. Note it down. Everyone has noted this down.
Just a minute.
All right. Done, everyone?
Done, sir.
All right, let me just share the test paper. You can see the test paper.
Yes, sir.
All right, I would request everyone to start the videos. I've started the focus mode. All right, you have 30 minutes for this. All questions are compulsory. All the best. No, Gulsum, I cannot see your video currently.
Now can you see my video?
No, not even now. Right.
There's
And
some problem.
Ishan, Ronaldo, Shikani.
Sir, I am on a different device, so I don't have camera on this.
All right. So this is the last warning for everyone. For tests, please on your video. All right, prepare your videos. All right. All right, last 5 minutes. All the students need to make the PDF and send the answers.
Sir, what are the total marks of this test?
Total marks would be 1 mark for this, 4, 7, 10, 12 marks.
And sir, second question will be of how much marks?
Sorry,
How much marks does the second question carry?
the second question has 3 marks. All right, this is 1 mark, 3, 3, 3, 2. All right, your time is up. Everyone, please make the PDF and share the test.
So I'll just
papers
go
with
and get
me.
my phone.
All right, no worries. All right, everyone, this is clear.
Yes.
Please make a PDF and then send the answer sheet. All right, I'm stopping the share. I should get your answer sheet in 2 minutes. All right. Or else you can leave the Zoom and send the answer sheet on WhatsApp.
Okay, sir.
That's all for today. All right. See you in
Thank
the
you, sir.
next class, guys. Take care.
Thank you.
Thank you, sir.
All
Thank you, sir.
right.